Welcome to this LabRat digital laboratory. Today I want to talk about elliptical and circular orbits. Now, in the pictures below, the blue depicts an elliptical orbit. And from geometry, recall that an ellipse has two distinct foci. On the right, we have a circular orbit. Now, if you also recall that a circle is a special ellipse to where both foci are stacked up on top of one another. This means that all orbits are elliptical in nature, even if it's a circle. There are Earth-centered orbits and Sun-centered orbits, and the terminology for each is slightly different. Now, the lowest point in an Earth-centered orbit is known as perigee. That's the shortest distance between the Earth and the satellite. The highest point in the orbit is known as apogee. However, for a Sun-centered orbit, perihelion is the lowest point in the orbit, and aphelion is the highest point. Calculate the velocity of a circular orbit using this equation shown here, where velocity is equal to the square root of the gravitational constant divided by the orbital radius above the Earth's center. Now, the orbital radius is calculated by taking the Earth's radius, shown here, and adding to it the height of the orbit above the surface of the Earth. Now, if you make this calculation, you'll notice that the velocity is constant throughout the entire orbit. However, in elliptical orbits, the satellite's velocity is always changing. Now, you can easily calculate the velocity at perigee, the lowest point in the orbit, and the velocity at apogee, the highest point in the orbit, using these two equations. They're somewhat similar to the circular orbit calculation. However, in this case, we have a factor of 2 involved, and we utilize the orbital energy, which is calculated as follows. The orbital energy is a gravitational constant divided by the major axis of the ellipse. And notice, however, that this value is always negative. Now, in this simple animation, I'm showing a difference between a circular orbit in green and an elliptical orbit in red. You should notice that the satellite's velocity in the circular orbit is constant, and the Earth is centered in the middle of the orbit. Now, the red elliptical orbit, the velocity of the satellite changes. Here at apogee, you should notice the velocity is slowing down, and as the satellite falls back towards Earth, it speeds up, with its maximum velocity being here at perigee. Again, minimum velocity at apogee, maximum velocity at perigee. Now, again, for the circular orbit, the velocity is constant and doesn't change from one point to another. Well, that wraps it up for this digital lab on circular and elliptical orbits. Make sure you go to labratscientific.com for more detailed information.